Hello class, welcome back to my YouTube channel, and for today I'll be your teacher in mathematics, and our lesson is about the lesson 20, the basic properties of logarithms. So we are going to discuss the properties and the laws of logarithm. So let's have first the basic properties of logarithm. So let's say we have b and x be the real numbers such that the b or your base is greater than and not equal to 1. So let's have the first property. So our b here is the base. So log base b of 1 is equals to 0. So the exponent here is 0. If we have b raised to 0, that is always equals to 1. So any value, any expressions that we raise to 0, if we have a 0 exponent, it will be equals to 1, always equals to 1. Next property, we have log base b power of b raised to x equals to x. So this is one property that we've already used in our previous topic. So when we have a power which also has an exponent and your power, the base of the power is the same as the base of your logarithm, then the exponent, the whole logarithm will be equals to the exponent of your power, so the x. Next one, the last one, we have b raised to, so our exponent is a logarithm, so we have log base b of x. So since we have same as your basis, as the basis of your logarithm to your base, then the value of your power and the exponent will be your exponent, or the equals to x. So to further understand those properties, let's have examples. So find the value of the following logarithmic expressions. So in our first topic, the lesson 18 rather, we've already encountered the logarithmic expressions and the exponential expressions. So let's find the value of those logarithmic expressions. First example, we have log 10. So this log 10 is an example of common logarithm, meaning our base here, so we did not write the base, meaning the base is equals to 10. So what will be the exponent or the equivalent of this log 10 if we have a base 10 and the equivalent 10, or the power? So the value will be, the answer will be equals to 1. So since we have a base here of 10 and it should be equals to 1, so let's find the exponent. So 10 raised to 1, that is equals to power 10. So 10 raised to 1. Next example, we have ln e raised to 3. So the ln is the natural logarithm wherein your base is e, or a value of 2.71 approximately, and so on. So the answer will be, so ln of n is the same as to log base e raised to 3. So since we have same bases here, log b and b raised to 3, so the value will be equals to 3, sorry, the exponent of your base. So this is the same as the second property. And last example, we have log base 4 of 64. So we need to find the exponent of the 4 that will be equals to 64. So the answer is log 4. So 64 is the same to 4 raised to 3. So the exponent is 3. So 4 times 4, that is 16. 16 times 4, that is equals to 64. So now let's have another examples. Find the value of the following logarithmic expressions. Again, fourth example, let's have log base 5 of 125. So we have a base 5. What will be the exponent to have an equivalent value of 1 over 125? So we have log of 5. And this 1 over 125 is the same to 5 raised to negative 3. That means negative 3 is our exponent. So equals to negative 3. How? When we have negative exponent, that would mean we need to turn this value, its in numerator, turn it we need to turn it to become the denominator. So we have 1 over 5 raised to 3. And 5 raised to 3 is equals to 125. 5 times 5, 25 times 5, that is 125. So the exponent is equals to negative 3. The exponent of positive 5 is negative 3 to have a value of 1 over 125. Fifth example, we have 5 log 5, 2. So the value here will be equals to 2. How? So when we have same value here and the log base, same value multiplied to your log with the base, same value with the base multiplied to your log, then the value of your power will remain. So this will become equals to 1. And it's also this logarithmic is also equals to log with the base 5, 2 raised to 5. So the value will remain as the value will become 2. Next, we have log 1. So the base here is 10. So we have 1 as the power. So meaning the value is the value of your exponent is equals to 0. Now, let's discuss the different laws of logarithm. So we have 3 here. We'll discuss 3 laws of logarithm. So let b or your base greater than 2, 0. That means we just have positive big values of your bases. And it should not be equals to 1. So we let n as an element of real numbers for u is greater than 0 and v is greater than to 0. So these are the variables that we're going to use, the n, u, and v. Then we have this exponents, proper laws rather. So we have log base b power of u times b. So we have here a product of u times b. So values of u and b. That is equals to log base b power of u plus, so since we have multiplication of values u times b here, u and b here, so when we turn it to a logarithmic, we have plus log base b of u plus log b of v. So this law is called the product rule, law of logarithms. Let's have another law. We have log base b. This time we have u divided by v. So we have u over v. So this is division. So we have first here multiplication. So this one is a quotient rule. So quotient rule defines to be log base b u minus. So we need to minus the log of this v value. So log b base b of v. So this again is the quotient rule. Next, and the last, we have log base b u raised to n. So our n here is another value wherein we raise the power. So we have, this is also equals to n log b of u. So this is called power rule.